So the first thing that we're going to start with is switching your calculator into degree mode. Remember, go into where you are doing your calculations, either the scratch pad or the document that you are using. Go to the document button, and then go to your settings and status and change your setting to degrees. You do have to make default, so make sure you do that. Everyone should be in degrees to start with. Now, here's the thing. We talk about not wanting to switch between degrees and radians, and it's a pain. Okay, well, it's a couple buttons on your calculator, and your directions make it extremely obvious as to which one you should be in. That will be on every question. Either 0 to 360, which is telling you, give me the answers between 0 and 360 in terms of degrees, or it will say between 0 and 2 pi, which means go in terms of radians. Okay? Super easy to do on your calculator. We'll start with the easy questions. If I would like to solve this equation in question 1, what exactly are we solving for there? The angle, theta. How do we solve for an angle in our calculator? Inverse. So in my calculator, once I'm sure I'm in degree mode, I am going to do the inverse sine of negative 0.82. Your answers should all be positive. Okay? Now, that's going to throw a wrench into some things for you because of how your calculator gives you your answer. When you plug in the inverse sine of negative 0.82, making sure that your calculator's in degrees, what answer do we get out to begin with? Negative about how many degrees? 55. Negative 55 degrees. Okay, here's how we are getting our answers, multiple answers for this question based off the fact that the calculator gave us this. Okay, do we remember a little bit about all students take calculus? Yes. Okay. In the terms of that, we have to ask ourselves in this question from the beginning here, our sine value was a negative number. Where in this is sine a negative number? The bottom two, which means how many answers am I going to actually have for this question? 2. Which one has the calculator given me at this point? Third or fourth quadrant? Fourth quadrant. It's telling me this is negative 55 degrees, and if I'd like to write that as a positive answer, how do I do that? 360 minus 55 gives me my first answer of 305 degrees. How am I going to get my other answer? Okay, which of the angles in here do I know? What did we call this angle? The reference angle, right? That one's negative 55. This is also a reference angle of 55 degrees. So how am I going to get my second answer? 180 plus 55, which gives me my second answer of what? 235. So your calculator this is the tricky part of this. When using your calculator, it's not going to necessarily give you all of the right answers. Typically, I do expect 2 answers for each of these. There are certain cases in which you only get 1 answer, and that's okay. You will just have to think about that. But for right now, we're going to operate under the expectation that we have 2 answers, and we keep them both between 0 and 360 as the directions have told us. Any questions about this particular one before we move on? Because there was no actual solving involved in this problem, other than what we typed in our calculator and thinking about the answers. We are going to add stuff to this, of course, right? No, it's not it. It's okay, though. All right, so let's take a look at question 2. First and foremost, I have to solve for the trig function itself. So we've added one step to this. I got to get the cotangent by itself. What do I have to get rid of? The 5, right? So we're going to add in some solving to this, which is where our identities are going to come back into this. Once you have the trig function itself by itself, this is where I draw my all students take calculus picture. Cotangent is the reciprocal of what? Tangent. So we're thinking, where is tangent and cotangent positive there? First and third. So I stop before I ever type it in my calculator. This is a positive number. That's what I am using to draw my picture. Okay, that's always where we get a little bit stuck. Where do we stop? Once your trig function is solved for, take a look at that number. That's what you look at for your picture. Now, what are we going to type into our calculators? Inverse cotangent of 12 over 5. If it gives me a number between 0 and 360, then that is my first answer. The last one gave us a negative to start with, right? So what does the inverse cotangent of 12 over 5 give me? Okay, so rounded to 23 degrees. Is that one of my answers? Yes. Yes, ma'am.
Could you also say tangent of 5 over 12?
Yes. You can also do the reciprocal of that and make it tangent is equal to 5 over 12. They used to say always do the reciprocals because of the calculators that we were using. But the Inspires have the inverses of all of them, so it doesn't really matter. So this first answer is 23 degrees. The reference angle is the same, so how do I get my second answer? Add 180. So my second answer is what? 203. Any issues with this to begin with here? Okay. Flipping to the back, we're going to do just a couple more of these. To begin with, on the back, we're solving for the cosine on question 3. So, how do I get cosine by itself?
You divide by 3.
First, I would do what?
Subtract by 9.
Subtract 9.
I just thought that was on the other side.
Which gives me the negative 2 over here. Then I divide by 3. So we get cosine is equal to negative 2/3. Here is where we stop and draw ourselves a picture. Cosine is what kind of value? Negative. So what quadrants are we in for cosine being a negative value? Second and third. So that's where I stop and draw my picture before I type it in my calculator. Now, what am I going to type in my calculator? Okay, inverse cosine of negative 2/3. Okay. What does the inverse cosine of negative 2/3 give me as an answer? 132. Okay. That is my first answer because that's in the second quadrant. Now, someone tell me one extra thing we're going to have to do on this problem. Find the reference angle. The 132 is from here to here.
So you did 9.
Okay.
132 minus
So I can, in this case, the reference angle is going to be down here. So how am I going to find the reference angle? 180 minus 132 gives me this reference angle of 48. I use the same reference angle over here to find my second answer in the third quadrant. 180 plus 48 gives me a second answer of what? 228. Yes? 360 minus 132. It works in that case, yes. Not in every single one, no. It just depends on the setups and where they're positives and negatives. Like tangents are always across from each other, so they're always 180 apart. So there's different rules. All right, the last one we're going to do involving degrees is question 4. Question 4 has a little bit of something different to it. When we solve for, it has a cosine squared in it, right? Okay, so it's not actually that bad because it's just solving normally here. All right, so how do we get cosine by itself? Add 3, divide by 4 to start with. You can do that in one step if you're comfortable. And how do I get rid of a squared on anything? Square root. Now, what do you have to be careful of when you square root things? Okay. What do you put in front? Plus or minus. This is very important. Why is this very important? Because how many answers am I going to get for this one? 4. 2 positives, 2 negatives. Okay? You were right on that. How do I square root this? Can I square root 3? No. Can I square root 4? Yes. Now, someone tell me why I am not going to type this in my calculator. Because where have we seen this number before? Our chart. Okay? So there are some of these that are chart numbers that we will recognize. These will tend to be on your non-calculator section of your test. Okay? So when you get the square root of 3 over 2, I immediately go to my chart. In my chart, what reference angle has a cosine value of root 3 over 2? 30 for cosine, right? Now, if you would like to draw yourself an all students take calculus picture for this, you may, but really it's the 30-degree reference angle in every quadrant because you want both the positives and the negatives, right? So someone tell me, we've got 30, that's the first one. The 30-degree reference angle in the second quadrant is backwards 30, so what's my second answer? 150. Third quadrant, 30 degrees into the third quadrant is what? 210. And 30 degrees backwards into the fourth quadrant is what? 330. So this is really where we're headed for the rest of the chapter. Less of it is going to be calculator. More of it is going to be using your chart, unit, circle stuff. Okay? Any questions about degrees before we look at this in terms of radians? The process is not any different. However, what do we need to do immediately when we switch to the next page? Change the mode of your calculator. How would I know that? Just looking at this page. This. 0 to 2 pi. Notice this one has round your answers to 3 decimal places because radians are not as pretty as degrees, right? Just because they're just pies and ugly. No, it's not going to be any more difficult. It's really not, because you have your calculator for this stuff. All right, so real quick, switch your calculator into radians. What I would like for you to do on your own right now is solve question 1 for cosine. Figure out where cosine is a negative value in which quadrants, and find the first answer out of your calculator. Once you get to this place, cosine's a negative number. You know your answers are going to come in quadrants 2 and 3. We still type inverse cosine of this into our calculators, only this time we're going to get a lovely little decimal back out. Anyone have what that is? 1.772. Now, here's the major question for this. How do you know what answer that is? Okay, how do you know it's the one in quadrant 2 or quadrant 3? You do. Here's the trick to these. Remember, radians. 0, pi over 2, pi, 3 pi over 2, and 2 pi. If you want to know where that decimal is, you take pi and divide it by 2. That's about 1.57. What is pi? 3.14, right? Either way, that decimal is between those two, correct? So this is the 1.772. How am I going to find the reference angle?
Don't you subtract it from 3?
Okay, so to find that reference angle right there, you are going to do pi minus 1.772.
Where's pi on this calculator?
It is down to the bottom left.
Under
I thought we needed 3 decimal places.
We did. Why?
Like 3 past the decimal?
Yeah.
Oh.
Yeah.
It's not 6 figs.
So pi, yeah, I don't do sig figs, sorry. What is pi minus 1.772?
1.368.
1 point what?
1.368.
Okay. That is your reference angle. So this is also going to be 1.368. Therefore, how do you find your second answer? How do you find your second answer?
You add it to 3.14.
Pi plus 1.368.
So wait, do I have to type in pi or can I type 3.14?
I use the pi button always.
Oh, okay.
Please use the pi button in your calculator. Rounding it to 3.14 gives you immediate rounding errors. So pi plus 1.368 gives me a second answer for this one of what?
4.508.
4.508. Okay, I'm not going to care if you're just like slightly off on decimals. If you're pretty close to this, we're going to be okay. Okay. If someone rounded the reference angle too small or didn't use the pi button.
But I didn't.
You didn't?
Wait, how did you get?
I don't know.
I did pi minus.
That's just what someone told me. So hang on.
Oh, sorry, that's what I got.
4.914? Does that sound better?
4.511.
Okay, why do we have two different answers here?
You know what I'm
Oh, you're using 1.772. You need to do the reference angle of 1.36.
Oh.
Okay, part of that is the reference angle we said was 1.368. It rounds to 1.370, I think.
Whoa.
For pi, do we need to use 3.141?
Use the button.
Oh, that's
You should. Yeah, you should do pi plus your answer.
So wait,
Yep.
what are we trying to find?
The angle from 0 around to here.
So,
All right, so to get your second answer, you have to do pi plus that 1.369. You can use your answer key. That's always the preferable thing, to use your answer keys so that you don't round them off. So even when I'm saying pi plus 1.369, it should be pi button plus your answer that you got for 1.369, so it uses the whole decimal, which gives us that second answer of what? 4.511. All right. Now that we have that settled, let's take a minute and look at 2. The only reason these are a little bit more difficult to us is because we dislike decimals. That's just how it is.
You're better than fractions.
Yes, that's true. All right, so let's take a look at 2. My goal is to get the trig function by itself. So first things first. Shockingly, this one really people go weird places with. What do I need to get rid of first? The 3. That does not take the negative with it. Randomly, people will solve these things wrong. Negative cosecant is equal to 4. Therefore, cosecant is equal to negative 4. Now, what does cosecant go with? Sine. So our question is, where is sine negative? What quadrants? Yep, 3rd and 4th. Okay, so the first thing I'm going to do is type into my calculator the inverse cosecant of negative 4. You get a negative answer for this one. Can we have negative answers? No, because it says between 0 and 2 pi. Where is that negative answer? It's the one in quadrant 4. Anytime you get a negative answer, it's always going to be in quadrant 4. That's just how your calculator works. So that's kind of like a reference point for you to keep in mind. So again, when I do inverse cosecant of negative 4, my calculator gives me negative 0.52253. I can talk, yes. What is that answer in a positive radian, or how would I find that?
Add 2 pi,
I would say 2 pi plus my answer, yes.
so that gets you 6.03.
Okay, so 2 pi plus my answer in my calculator gives me a first answer of 6.031.
Where did you add it to 2 pi?
Because this is 2 pi right here. So you're going backwards 0.253 from 2 pi. So it's really 2 pi minus that.
Yeah, okay, yeah.
Yeah. But that negative 0.253 is not useless to us either. What is it? It's the reference angle, only you use the positive version of it. So how am I going to get my second answer here?
You subtract from
I'm going forward into the quadrant 3. So I'm going to do pi plus 0.253, or your answer in a positive number, either way. I get my second answer of 3.394.
Wait, what did you add it to?
Pi.
What did you add to pi?
The reference angle, 0.253. So on your own, we're going to try question 3. We're going to do 4 after that, and just a couple more, and we will be done for the day. First answer being 0.927. That is also your reference angle. So you are going to use that to find your second answer. What am I going to type in my calculator to find my second answer?
2 pi minus
2 pi minus my answer, right? So 2 pi minus answer gives me 5.356. Okay, last one on this page. We'll do one or two more and we will be done. On this number 4, it's similar to the one we did on the previous page with the cosine squared, only when I'm getting rid of the squared on the tangent, I also need to remember when I square root, what must I do? Plus minus. Now, again, just like that one, we are not going to type this in our calculator because in our chart somewhere, we have where tangent is equal to 1. Now, keep in mind, we're in terms of radians here, right? Okay, so my first answer to this is pi over 4. How many answers will I have since it's plus minus? 4. So it is the pi over 4 reference angle in every quadrant. So if you have your unit circle written down, you can simply look for all the pi over 4s.
4, 5 pi over 4 is 7.
Yes. This is why I prefer to use the chart, because these are much friendlier than all of the decimals that you get from your calculator.
Yeah.
Get comfortable with those because life will be better if you do. Okay? So it's the positive 1, negative 1 in every quadrant going around your circle. All right. Because of the plus or minus from your square root. Okay. All right, we're going to finish up on the back of this page real quick. I said the last question on this page. I know. I will tell you the homework in a minute. All right, these are all using your chart. Okay? So, a lot of these require very little actual math and mostly just thinking about your unit circle and your chart. Okay? So there's 2 parts to this question. We are, first of all, not going to answer in both degrees and radians. We're just going to go with radians. More of this stuff is used in radians in calculus than in degrees. So we're going to focus on radians. There are 2 things in question 1. You need to meet both conditions. Cosine is equal to negative root 3 over 2, and tangent is what? What are they saying there?
Greater than 0.
Which is what? Positive. They're saying tangent is positive. You could think of it that way, but it's really telling you to narrow down the quadrants here. So the first thing I look at is this. It could have an infinite number of answers if it went past 2 pi, but it doesn't. It keeps us in one circle. Okay? So the first thing that I look at is they're telling me tangent's positive. What quadrants does that eliminate for us?
First and fourth.
It keeps us in the first, and it keeps us in the third, right? It eliminates the second and the fourth because tangent is negative in those quadrants, right? Now let's further narrow this down. What kind of number is cosine here? It's a negative, which eliminates one more quadrant. Which one? 1. Okay, so I need to figure out where cosine is negative root 3 over 2 only in the third quadrant. The tangent took out the first 2. The cosine being negative took out quadrant 1. Therefore, we're only in quadrant 3. How do I find that using my chart? We use our reference angles. So go in your chart. Where is cosine equal to root 3 over 2 in your chart? Okay, at pi over 6, that is my reference angle that I'm going to use right here. Pi over 6 past pi, or the pi over 6 reference angle in quadrant 3 gives me only one answer for this question, and it is what? 7 pi over 6. Don't use your calculator. Yeah. This is why I literally make these non-calculator sections so that you aren't tempted to do that. Because we always want to just type stuff in our calculators if we have it. Okay? All right. Any questions on that one? So this is an example of where you have only one answer because of all the conditions. It narrowed it down. Okay? Question 2 is very similar. We're going to use our chart for that. Sine is 0 and cosine is negative 1 at the same time. Okay? So what I'm going to look for in my chart is something close to this. Okay? Clearly we don't have negatives in our chart, right? So where's the closest thing to that happening at the same time? It's kind of close to it at 0, right? Sine is 0 and cosine is what? 1. Well, let's think about it. Where if over here sine is 0 and cosine is 1 at 0, where would sine be 0 and cosine be negative 1? On the opposite side, which is what over here? Pi. Notice that there was actually no math involved and that was all done in your head. Okay? There are lots of things like that in this chapter where you're just going to be thinking about the answer. Okay? More of the chapter is going to be this kind of stuff and solving using your identities, and less of it is going to be with your calculator. We're going to get comfortable with the calculator stuff today, and then the rest of the time will be spent using our chart and stuff. Okay? I do not believe that I would like to do the other two because we've done calculator stuff, so we're going to get to homework.
God bless.